Okay, everyone. So I think we can start the session now. So good evening, everyone. Welcome to the day second of ML Bootcamp, and today we'll learn about uh, Python libraries like Numpy, Panda, and TensorFlow, and we'll also look into some data cleaning practices. So let me share my screen. Okay, so can anyone tell me is my screen is sharing or not?
Yes, Arman, you can move it.
Okay, so today we'll be using Google Collaboratory, and this provides an Jupyter environment, and it is used for training, and it will provide every user a RAM and a CPU so that they can practice on basically on ML projects. So let's start with Numpy. Numpy is a Python library and is used for handling arrays. The difference between the existing lists in Python is that they are very slow, and these numpys are almost 50 times better and faster than the Python list. The main reason behind is that in Python list, the non-homogeneous data can be stored. That is, the data belonging to different data types can be stored in a single array. So because of that, the elements of a list are not stored in a contiguous memory location. So this issue is solved by numpys where only homogeneous data types are stored in this array. So let's start. We we can import the library by typing import numpy as np. You can take any name, but generally as a convention we use np. So if anyone has an error, they can just write an exclamatory sign pip install and the name of the package. So this what this will basically do is that it will install the package. If you don't have already, you can type this, and you can do it for pandas also and TensorFlow also. You can just change the name like this. But I have already installed, so no problem would be there. So let's start. We can create a numpy array like this. We can first like initialize a Python list like this, and then we can type np dot array, and we can pass that list, and we can also pass the data type we want. Repeat type is equal to int, or if we want float, we can write np dot float 32, float 32 or float 64, and we can print it like this. Initially it would take a time. Initially it would take some time. Some users may get a lag, but it would be just an initial thing. So let's carry forward. See here we have created a numpy array, and there are also ways you can create like this. A is equal to, or let's say we can take b dot. What this will, we will pass to three values: an initial cap, a final cap, and the difference between the values, like 3. So what it will do, it will take 1, and at a difference of 3, it will generate an array. See, you can see at the gap of 3, we can take a larger size. So starting with 1 and ending with 10, there are elements like 1, then there are gaps of 3, then there is 4, then there are gaps of 3, and then there is 7. And there are also the functions like np dot ones, np dot zeros, that will create arrays of entirely 0 elements and entirely 1 elements. Like, you can pass the size, or you can pass the shape of the array. See, we have passed the shape 3 comma 2, and it has created a two-dimensional array with a three-dimensional array with all the values having 1. And similarly there is also another np dot zeros. Same way you can pass the shape. Here we'll take 2 comma 3. You can here also pass the data type if you want, and I'm not. Uh, okay, so it's a comma 1. You can access the elements like normal, like we have done in that we do in Python. Like we pass the index, and we can print. So the first element is actually an array itself. So that's why it is printing this array. So what we have. So we can also pass strings. Also, it will do the conversion internally. So let's say I set the zeroth zeroth element to be 2. So after printing, you can see. Just wait for a sec. See, the value has been changed. So in traditional Python list, what we would do to append a list was like if D was a Python list, so we would do D plus is equal to 2. 2. So it would append the element 2 into the list. But here it will add the 2 on all the elements. It will not just append it, it will just take the summation over all the elements. See, so to append it, to append an element, you can add d dot append. So we'll pass the array of same size. So I think there is some issue over here. I'll get back to this afterwards. So just skip this. There may be a problem with this notebook because usually this would have been this would have worked. So you can also do matrix multiplication if we have two matrices. You can create n-dimensional matrices using numpys. So if these are two matrices, then we can do what is the okay. We have left a comma over. Okay, so if these are the two matrices, you can do uh, m1 into m2. It would do the multiplication element wise. So you can see the first element of both the matrices are 1. So 1 is over here, and the second element, the 0 1 position is of both elements are 2. So here we have 4, and we can do a dot product in p dot and write in p dot and pass the two matrices. So this will produce the dot. These all will be helpful while in machine learning is that when you are building your own model from scratch and not using like TensorFlow or scikit-learn, then you will need to know all this stuff. But generally, this will be useful while you are pre-processing the data and you are handling with null values, and this just goes along with the pandas library. So you can change the data type of any matrix. Like first, let me show. If if this is has integer of type 64, you can write m1 is equal to m1 dot as type, and then you can pass the data type that you want, like float 64. Right. To see the data type has been changed, all the elements are now of type float 64. So what next we can do with Numpy? Okay, so there is a method called reshape. It would change the size of, it would change the shape of the matrix of any array that you will pass. Let's say we have this matrix m1. So we can write m1 is equal to np dot reshape and pass this matrix and pass a new shape. Like if this is if one dimension, so if you had -1, it would automatically calculate what the rest of the values should be. So see, it has just created an entire array having all the elements. And let's let's say there is also a function called ravel. It will also just remove all the shapes, and it would all remove all the dimension and would create a single array. Let's say we have m2 over here. We do np dot ravel. Pass the, we need to just write np dot ravel and then pass the matrix or any array, any shape, any two-dimensional or more dimensional space, and it will create a single dimensional array. And let's move forward with pandas. I think this is enough for today. There is not much you need to learn right now, so let's move forward towards pandas. Pandas is a library, so let's write pandas over. So pandas is a Python library that is used for handling large data sets. It can be very useful while cleaning, while viewing, and
Mm.
while handling
Arman,
some
if
animals.
there are any issues around NumPy, you can ask it once, you know.
Yes, can you repeat what you are saying?
Yeah, I'm saying if anyone has any issues around NumPy, एक बार clear कर लो.
Okay, okay. So Piyush is saying if you assign access np dot append, this will if you assign access none or its values, it will never work. Let's try what Piyush is saying. If anyone has any doubts, they can just ask or they can write in the chat box. You can also create a habit of searching online because you cannot always remember all the code for all the methods. So you you just have to create the habit of knowing how the function would work, and you can just search online and you can get the solution. So while also with TensorFlow also you don't need have to remember all the codes. Just you need to know how things works and how they are internally working, and just you can search online and copy paste from that. So here it is saying np dot append, but we need to append on a different array. So there is no, I think, Where is it? No, I think it would not work because where it is appending to the value, there is no mention of an array where the values are being appended to. So I won't think. Okay, so over here I think it's there. So you need to pass it, I guess. So create a new array. Is equal to array. Okay, now we will write into that and we'll pass the matrix and then we'll need to pass the values like 0. Let's say this works or not. Okay, so what it needs is that it needs to pass both the values. We need to pass the actual array itself and then we need to pass the values that we need to append. So let's move on to pandas. So pandas is a library that is used to handle the large data sets and it creates data frames in the form of rows and tables, rows and columns. It creates the table for the data set that we need to work for our ML project or anything. We can also use it with matplotlib, which is a visualization library. So let's import pandas as well. We try to import pandas as PD. There's another library called scikit-learn that provides datasets and other ML ML algorithms. So we'll use a dataset called iris dataset. So for that we can write import from from sklearn dot datasets import load iris. So what this will do, it will load a dataset called iris. What dataset tells us is that the it is a classification problem where the columns are like sepal length, sepal width, petal length, and petal width, and we need to classify which type of flower it is. So we can we can create the x where the features we can access the features like this iris dot data and the y is the label values iris dot target. In pandas we can also import csv files or excel files. For that we'll need to write df. Let's say df is the name of our data frame and read csv and we need to pass the address or the location. So we'll not do this right now and we'll use this iris dataset. So for that we need to create a data frame called as df. So we'll write pd dot data frame and we'll need to pass the values of the all the columns. So we'll pass our x all the features and we'll need to pass the names as well. So we'll write here we need to pass a list. So for that we can write iris dot feature names. Feature names would just return all the names of the columns. Let's wait, it will create our data set. Pandas has no attribute data. Okay, so the D might be not capital. D dot I think I have. Okay, so the frame is also capital. The F in frame is also capital. So these issues will occur also to everybody. So Wait a minute. So generally, we'll be using VS Code, so we'll not be having such problems. Here, there is no autofill, so just look at that. We'll look at the data set. See over here. So the first four columns are sepal length, sepal width, petal length, and petal width. We can also append our labels column like this. We'll write df, and in square braces we can write the name we want, like labels, and we'll just pass in the values, which is so it will create another column named labels, and will show the values. So here, so these are the classes 0, 2, and we can print the name of the classes like this. Write classes is equal to iris dot target names. The target was the object that we created earlier, where when we load that I load iris data set. So target names. See, yes. These are the classes. If the indexer is 0, then it is setosa. If it is 2, then it is 𝒂𝒏𝒕𝒓𝒐𝒅𝒖𝒄𝒕𝒊𝒏𝒆, and so on. So next thing is that we can we can also accept, there's a function called head and tail. So if we'll write df.head, what it will do is that it will just display the first five rows, and similarly if we'll write df.tail, it will print the last five rows. And we can also pass the number of rows we want. Like if we'll write 10, then it will print the first 10 rows, and similarly in tail it will print the last 10 rows. There is a function called df.describe, which will just give the basic information about our data set. Uh, just wait a minute. So, so it will give the count of the values and see if there are null values. So if there are null values present in our data set, then all of them would not be 150. Some of them would be 149, 148 based on the number of null values. The mean would give the mean value from that column. Standard deviation would give the standard deviation. Minimum would give the minimum value. Maximum would give the maximum. And these percentages are actually the percentiles. What is the 25th percentile value, which is 5.1 for this first column, 2.8 for the second column, and so on. So let's move forward. Let's print the data set once again. We can also access different parts of data sets. You can just write df.ilog, and if we want to access first 3 rows, let's say, so we can write 0, semicolon, and 4. If we want 4 rows, then we'll write 5 over here. We'll write comma, and if we want all the columns, we'll write a semicolon over here again. So we need to pass over here all the ranges. So let's say I have written 0 and 4. So first 4 rows are over here, printed over here, and I had not mentioned any range over there, so all the columns are printed. So if I had written just 0, then the first column will print, only the first column will print over here. So see, you can see the first 4 rows, and the first column is there. And this thing about ilog is that it prints based on the number of row, and there is also a function called df.log. So what it would do is that it will print on the basis of indexes that are present over here, like 0, 1, 2, 3. So it will write the same thing again. Now there is no much effect here, but in future, like when we delete any row, let's say I'll drop the first row. Df dot drop, we'll write, and we'll pass the index over here. The first row is deleted, and in the index column, the the values have not been updated. What it means is that the indexes are not affected. So when we'll print this 𝑰𝒏 again, let's see here. So to see the here it has not been deleted because in the drop column we had, by default there is a argument called in place which is set to false. So if we set to true, then the values in the actual table will be affected. So here when we print again, the value would just go. So here now the actual values in the table have been deleted. But if we'll print the zeroth row through the log function, df.log, then there would be an error. df.log 0. See, here the error is there because there is no index value with value 0. In the index column, there is no 0 value. That's why there is an error over here. We can also reset the values by typing df dot reset index. You have to pass in place as true so that it would affect the main data set. And in Python, in true value, you have to keep the capital T and drop is equal to true. What drop would do is that it would delete. If we take drop is equal to false, wait, so see why if we had not written drop is equal to true, or just had written drop is equal to false, then it had created a separate column called index, and it would have the values like before, like it would have one over here. So we'll need to write drop is equal to true in order to delete this column. Okay, so since I had run the same code again, that's why it has not deleted this column, because it had created this column before. So to delete any column, we can write del df and pass the column name like. I'll show this drop thing again because I had executed the same command. That's why it was not working. So let me show you again. Let's drop a few columns now. Df drop. Drop this is equal to true. So it would delete the first two rows. The NP range would pass an array containing 0, 1, and 2. See, the first three rows have been deleted till the index 2. So now when I do this df dot reset index, in place is equal to 2, and Crop equal to true. Now see, now this time no other column has been created. So I think that's it. Now Ritu will do some exercise on data cleaning, and then after that we'll look into TensorFlow once again. Okay, so Ritu, can
Yes,
you take over?
Arman, am I audible?
Yes, yes.
Okay, so let me share my screen. Now you may have understood what Numpy and pandas really is. So, um, beginning with what data cleaning is, why data cleaning is required, and to understand your data. So first we will import the important libraries like pandas and Numpy, and trained train test split is for another use. Now first important use is to import the important libraries, and then we will first try to get the basic understanding of our data. Like we will first read the data set, and then we will ask some basic questions like how does the data look like. We will use data dot head to get basic understanding of the information about the data, and checking the shape. Now there are 918 rows and 12 columns. So what is the data type of columns? Now you can see there are 11 columns, and we have float. Age is the numerical column, and chest pain type and others are the categorical columns. So it is basically a hard data set to predict the heart disease, like whether the person has heart disease or not. 1 denotes yes and 0 denotes no, and these are all the symptoms. So to check the correlation between columns, we use data dot correlation, and one means every column has the correlation one with itself, and negative correlation means that if x is increasing then y is decreasing, and then positive correlation means that if one variable increases the other variable also increases. There is a direct relationship between the two columns. Then how does the data look like mathematically? We use the data dot describe. Are there any missing values? So it is very important to check, since the data cleaning is a crucial step in machine learning process, and the primary reason for data cleaning is to ensure that data is accurate, complete, and reliable. And data cleaning involves the removing errors, duplicates, inconsistencies, and missing values from the data set. If the data used in the machine learning models is not clean, it can lead to incorrect predictions and inaccurate results, which is obviously not good, and it can affect the accuracy of the model and quality of the data and the model. So, and also the all the machine learning algorithms only work on the imputed data set. They are not coded in a way that they can be applied on the unclean data. So it is very much important for the quality and the accuracy of the model. We use data cleaning. So for data cleaning, we use there are some techniques like so basically in data cleaning, what we have two choices. Either we can remove them or we can impute the values. So removing is not always the best option, because if we remove some values, we are basically losing some information. But if we impute the values, it will be valuable for us. So if for imputation, there are two methods: univariate and multivariate. So univariate, as the name suggests, uni means one and variate means variable. So we impute the values by using only one, by using the values of the same column, like the simple imputation, in which we use the mean, median, and mode. And in multivariate, we use gain and imputation, as you can see. So we will first chart, this is the heat map, and we can see there are null values highlighted in the yellow color. So first is the if you first option is to remove them. So when you remove missing data values, that approach is called complete case analysis. CCA means literally analyzing only those observations for which there is no information in all of the variables in the data set. So complete case analysis means list-wise deletion of cases, and we there are some assumptions we use for complete case analysis is that the data should be missing completely at random. Like you can see, the data should be missing completely at random places and not in chunks, like not in the beginning, and not in the chunks like the 50 rows from the beginning and the 50 rows in the end. So it should be in chunks, like randomly missing. So the data should be missing completely at random. It has some conditions, like it only used when the missing completely at random, and if the missing data is less than 5%, then only we apply CCA. If the missing data is greater than 5%, we don't apply, since it can distort the distribution of the data set. And also, if we remove the values from if the missing data is more than 5%, and if you are removing those rows, then we are obviously we are losing some valuable information basically. So it is not always a good idea to remove such columns. We can get the valuable insights from very little data. So the little data is so much crucial in the machine learning. So I will not suggest by using this technique, but it's just like you should know that it is one of those techniques to handle missing values. If any column has 90% missing values, then it is of no use, so you can simply remove the column. And advantages of as you can see, we can first see we can check the null values, the percentage of null values in each column, like age, sex, chest pain type, resting BP. So the age column has 4% values, and normally all the columns have less than 5%. But as I said that we cannot remove all these values. At we have 900 rows, and if we remove all these rows, and we are basically losing some data. So uh, this is to fetch the only those columns whose missing value is less than 5% and greater than 0. So these are the columns. Now we are checking the distribution of the column before applying CCA. And after for CCA we use a drop any. We use the drop any function, and we are passing the two columns like age and rest ECG. I have only applied CC on two columns because it is not it is not beneficial to apply on so many columns for the reason I stated above. So now you can check after applying CC on two columns like age and resting ECG. Before that we have 4% missing values and 2% missing values, but after applying CCA we have 0 and 0 values. So now our data set looks good. Now simple imputation. So what are the advantages of CCA? Is that it is easy to implement because you can easily remove the values. Removing the values is less hectic than actually imputing them. So, and disadvantage also, the advantage is that it preserves the variable distribution. Matlab, like you can see, this distribution is retained even after removing the value, since we are only removing the data less than 5%. And disadvantage include because we can lose some valuable information. So that is the major drawback, since machine learning models are require some valuable data insights. Then second is simple imputation. As I have told earlier, that we can use the univariate and multivariate method. So univariate means using only one column to impute its values. Like if we have the missing value in one column, like in each column. So we will use the mean of that column to impute the values. So means using the making use of that column only to impute the values of that column. Now checking the distribution before imputation, we can see the distribution is like skewed, left skewed. So yes, the distribution is left skewed. So when to use NCAR, when to use simple imputation is when the data is missing completely at random, as I have told earlier that it should be missing in randomly and not in chunks, like the 50 rows from the beginning or 50 rows in the end or in the somewhere in the middle, and less than 5% values are missing. Now there are two ways to impute the missing values, by using the mean or either the median. And mode for categorical columns. So mean is basically used when the data is numeric and not skewed. Uh, as you can see, the distribution of the each column is left skewed, like the left tail is longer than the right tail. So we cannot use mean here, but resting BP is not skewed, so I will do mean imputation in it. Median imputation is done when the data is numeric and skewed, like the age, cholesterol, and maximum heart rate, and the mode is used to string or the categorical columns. Checking the Now we have seen the importing the data set, and we are checking the null values. So considering these columns, we have less than, as I have told earlier, less than 5% values are missing. And so imputing is one of the best ways to handle the missing values instead of removing them. So we have checked, as I have told earlier, we check the skewness. Now the age column has negative skewness, means it is left skewed. The left tail is longer than the right tail, as you can see. And the resting BP is 0. That means it has normal distribution, and the cholesterol has uh, left skewed. Fasting BP is right skewed. So positive values indicate that data are skewed right. Negative values for the skewness indicate the data are skewed left, and the skewness for a normal distribution is 0. Imputation for numerical columns, we have used median for age column, because I have told that the age column is left skewed because it has negative value. So I have used the median. We use median for skewed data, few skewed columns. So we have used median to impute the values of the age column, then cholesterol, maximum heart rate, and old peak. So this is for reference. Like we can see the median of the age column is 54. The 50% denotes the median. It is also known as the second quartile. And the cholesterol we have 223, maximum heart rate we have 138, and for old peak we have 0.6. So these values will be imputed. And for categorical columns, we use the mode. Mode is the most frequent category we use to impute the data, missing data in the categorical columns. So we have used the mode. Mode is simply basically the category which is frequently occurring in the will be replaced at the null places, like fasting blood sugar, exercise angina, resting ECG, chest pain type. And after doing successful, like using mean, median, and mode imputation, mean, median in the numerical columns and the mode in the categorical columns, we have this zero null values. So this is the second way of imputing values after CCA. So CCA is not beneficial if you are removing some data that you are doing. Um, you are not doing good for your machine learning model, because the accuracy will automatically be decreased. So imputing by mean, median is a good choice. And checking this distribution after imputation, you can see that the distribution is like same almost. But if you have this is because we have 900 rows. If you're working on a very large data set, like 40 to 50,000 rows, so we can see that the distribution of the KDEs changes after using mean and median. So because the values increases in the middle after imputing, because mean median values increases, so this curve uh, gets a more steeper from the middle. So some advantages and disadvantages is that we can use simple imputation when we have data missing completely at random and more than 5% values are missing. But disadvantage is that we can the shape of the data set is distorted, like we will get more steeper KDE after imputation, and we can get some outliers too. Next is arbitrary value imputation. This technique states that we group the missing values in a column and assign them to a new value that is far away from the range of that column. Mostly we use values like 999 not missing or not defined for numerical. So arbitrary value imputation is we used particularly for highlighting um, arbitrary value imputation basically we used to highlight the missingness of the data, like when we have to when we have to matlab, when we have to make the algorithm notice that we have missing values here, so we use the arbitrary value, like the value which is far away from the range of that column. Like if we would have used in arbitrary value imputation, we can use minus triple line in the age column, which is completely nonsense, but it will may help the algorithm to know that yes, here the values are missing, and it might be beneficial for the machine learning algorithm to highlight the importance of the missingness in the data. So benefit is that it is easy to apply, and disadvantage is that it is PDF is distorted and the variance is changed. Then end of distribution imputation. Um, if we talk about the arbitrary, एक second. Yes, end of distribution, end of distribution imputation. In this, in arbitrary value imputation, we just only the code is same, but you can just replace the 999 or -1 from the mean and median. So the code is completely same. So end of distribution imputation, we use the end values, not the arbitrary values, but somewhere in the end. If there is suspicion that the missing value is not at random, then capturing that information is important. Like as I have highlighted the fact that sometimes highlighting the importance of the missing data can be crucial or may benefit to the machine learning algorithm. One want to replace missing data with values that are at the tails of the distribution of the variable, like as you can see. In this, we impute the data which are at the extreme ends, like from the three standard deviations away from the mean. So it is completely same as that of arbitrary value imputation, but it's just like we use the values at the end, uh, at the extreme ends of the distribution, and not the random values. So the benefit of end of distribution imputation is that it is easy to apply, but disadvantage is that the PDF may change and the covariance changes, and the variance can be increase or decrease. So in all the three methods, like simple imputation, arbitrary value imputation, and end of distribution imputation, we have the disadvantage that the variance changes. But in KNN imputation is another method. It is a multivariate method for imputing missing values. Um, it is a machine learning technique used to impute missing values in the data. It is stands for k-nearest neighbors, which is a type of algorithm used for classification and regression problem. The idea behind KNN imputation is to use the values of the k nearest neighbors of a missing values to indicate to estimate its value. This is done by computing the distance between the missing value and all the other values in the data set. So uh, we can see the null values in the data. Then we can import the knn imputer. We can make an object of the function and passing the number of neighbors. Then we can uh, use the object on the fit function to fit, and using the fit function on the columns to basically to fit the imputer object on the columns like age, maximum heart rate, cholesterol, and node peak, which have uh, missing values. So now after knn imputation, we have the maximum. We have the zero value. So knn imputation is one of the best techniques to impute data. After all of this, like we have the accuracy of the data increases and the distribution remains the same, and basically the values which we are imputing are more accurate. Like in the mean and median, we are basically using the average of the others of the column, but in knn imputation it is good. Now we can see the heat map. After removing the values, we have zero null values in the column. Then proceeding to the exploratory data analysis. So exploratory data analysis is an approach to analyze the data using visual techniques, and it is used to discover trends, patterns, or to check assumptions with the help of statistical summary and graphical representations. Its main purpose is to drive valuable insights from the dataset, and there are three types of EDA, like univariate analysis. UD means one, and variate means variable. So in univariate analysis, there is only one dependable variable. That means we do EDA only on one column without using other columns. The objective of univariate analysis is to derive the data, define and summarize it, and analyze the pattern present in it. Then in bivariate analysis, bi means two and variate means variable. So here are two variables. In this, we perform EDA on two variables. In this, scatterplot, heat maps, etc. are used. Then multivariate analysis, multi means many and variate means variable. So in this, we perform EDA on more than two variables. In this, pair plot is used. And I will perform all three types of EDA in this data set. Like you can use univariate analysis. We can see data.head, and using the count plot, as you can see, this is the univariate type. Since we are only working on the single column, we can get the readings like we can analyze that asymptomatic chest pain is the most common in humans, while the non-anginal pain is the second most common chest pain, and the typical angina is the least common. Then exercise angina, we have more than 500 people don't have exercise induced angina. Then similarly applying EDA on univariate, EDA on SG underscore slope. Then bivariate and multivariate analysis. Bivariate we use two columns like heart disease and resting BP. We can see we can see most one from the resting blood pressure group data. We 120 to 170 readings are indication of an heart disease. And in resting BP, distribution of the data is too close with each other. Like the first quartile starts from 95 and ends at 125, while the data from the 125 to 175 covers remaining data. And similarly, applying bivariate analysis on heart disease and cholesterol, we can see cholesterol levels between 150 to 350 are susceptible to heart diseases, and data starts from 0 but mean is near 100. And further histogram plot shows that majority lies between 180 to 350. So most of the people who are suffering from heart disease have high cholesterol levels, because as we have seen that the 150 to 350 are susceptible to heart diseases. But and also in our data set is it clearly it is evident from the fact that most of the people have cholesterol levels from 180 to 350. So we can use this EDA to get some valuable insights. As you can see, heart rate from 100 to 180 is contributing in the heart disease. Like 100 to 180 is too high for normal human beings. Then you can use the scatter plots to plot the data points, and cross tab to basically see the correlation between two columns. And it is basically the correlation function that we have used. It's just like we are plotting it to check the heat map. And the heat map the heat map is basically used to check the collinearity of the multiple variables in the data set, and the data.cor was used in the code to show the correlation between the values. So this is basically to check the correlation between the two columns. And yes, you can see the heat map which I was talking about. Every column has the correlation 1 with itself, like the heart disease has the correlation 1. And positive correlation means if x is increasing, y also increases, like they have direct relationship between them. But negative correlation means if x is increasing, y is decreasing. Like um, if heart rate is increasing, then the resting blood pressure is decreasing. Like this, you can get endless insights from the data set by using such heat maps. Like you can see mm, cholesterol and fasting blood sugar. Like people who have more cholesterol have less blood sugar. And zero means um, it's like not in the it's like the zero means they have no correlation. So that's it. Then scatter plot we use to plot the data points to check to see the scattering of the data points between the resting pressure and the age column. And as you can see, the zero denotes, as you can see, the blue point shows that people are not suffering from heart disease, and the one denotes people are suffering from heart disease. So you can automate this time consuming EDA task by using pandas profiling within seconds. So we can import this library called the pandas profiling, and it is, you can use it like to basically cut off your 90% of the hectic of the EDA, like doing this chart plots and all of the stuff by simply using the pandas profiling. And we can import pandas spt from pandas profiling, its library, and you can import the profile report. We can make an object and we can give the data. Now we can convert this into the html file, and then you can see the pandas profiling has this report. Like it has given the report like the number of variables. Like we have 5 numeric columns, 6 categorical, and it gives the basically we all of the stuffs we have used so far, and it is giving us the summary of this. So you can see how the Python has now evolved so far. Like you can automate such tasks very easily within 4 lines of code. Like, and you can, it can be less hectic for you and also less time consuming. Like it can check like duplicate rows 0, missing cells 0.2%, missing number of missing cells 17, then distribution of all the single columns, mean, median, and zeros maximum values particularly specific to that column, which columns are highly correlated and which are not getting the categories resting BP, cholesterol, fasting blood sugar, resting ECG, and maximum heart rate. All the information, univariate analysis. Basically this is all that the univariate analysis that we were doing earlier. Like we were checking, we used to plot uh, we were checking plots, uh, we were plotting um, the single count plot and etc to check the distribution of the particularly specifically seeing the distribution of the data. But after using the pandas profiling, you can see we can automate such tasks, and it's amazing. So you can see every little information about the particular column that we were using so far. By doing the manually, it has automated. Now you can see in the interactions, you can see it has, this is the YV rate analysis, like the maximum heart rate and the cholesterol, resting BP and age. So we can check the scatter plot, that we were using the scatter plot earlier between the two columns manually, but now after 4 lines of code we can easily check variables, intersections, and the correlations. As I told you that we were using correlations heat map for manually doing such tasks, but more detail like Pearson's candles to check the correlation between the columns, missing values that we were using, we were applying using code to check the missing values. We can easily see which columns has the missing values and how much. Then first rows, whether the data is not missing at random, like as you can see that the data is missing at random and not in chunks, like as I have told earlier that the first rows should not be missing in chunks or in the middle and the last. So this is beneficial to know that our data is missing at random last rows. So that's it. That's how you can automate. Python has evolved so far that you can now automate such tasks within few lines of code. So as we were using manually doing the scatter plots, heat maps, it is quite time consuming and hectic for, it might be hectic to some people, but pandas profiling can reduce 50% of that task. So it can do it for you. So that's all for now. Now hand over to you, Arman, and now you Arman is here to give the mathematical intuition behind the tensor flow. So thank you.
Okay, so let me share my screen. Okay, so today we'll look into TensorFlow. We'll not go deep into Keras. We'll do it tomorrow while we are creating our project. So let's import TensorFlow right away. Try to import TensorFlow as TF. Just keep in mind that the TensorFlow version is greater than 2.0, because before that, when we had to create our sessions, we had to create our graph. So now after the version 2.0, there is something called eager execution, where where the interpreter just reads the code line by line, and we can directly print our tensors. We can directly perform operations on our tensors. Before the version 2.0, we would have not able to do this task. So in this version also, the graph is there, but we need to disable the eager execution method. So let's first check which version of TensorFlow is right now we are using. So let's type tf dot underscore underscore version. Okay, nice. So this is the version 12, 2.12. So you will see that there is quite a bit similarity between NumPys and TensorFlow. There are also similar functions, like we had used like np.1s, np.0s. The same functions are there in TensorFlow. So first we'll look into constants, which are mutable tensors. We cannot change their values. So the code is like tf dot constant, and tf dot constant need to pass the array or tensor that you want. So you can write to print the tensor, you can just write tf dot print and just pass the tensor a. So you can see it has created a tensor. So 1, 2, 3, it is an array. We can create n-dimensional tensors. So to look into more information, just type a and just execute the code. So see, the shape is 3 and the data type is in type 32, and it is a NumPy array. So tensors and NumPys are correlated and they work side by side. So the the Numpy arrays will also be compatible with the TensorFlow tensors. So you can also pass the data type here as read. So you can just write tf dot float if you want it in the float data type. So when you print this, you will get a float type tensor. So there are variables which are mutable tensors. You can write p is equal to tf dot variable, and you can pass the tensor. And you can change the values by using an assign function. Tf so the v is capital. So you can write tf dot assign. You can pass the array or the tensor. And you should know that the shape of the tensor should be same, otherwise an error would appear. Just wait. Okay, so it's like this. You'll just need to write b dot assign, and you'll need to remove this part also. So here the values change. See, the value has now been changed. Okay, so now there are also similar like tf dot ones, and you'll pass the shape that you want to come up to. So it will create a, a tensor of shape 2 comma 4, and all the values would be 1. And similarly there will be a function called tf dot zeros where all the values would be 0. Tf dot zeros, you need to pass the shape 4 comma 2. Okay, so this I had copied the matrix. So let's say these are the two matrices, and we can do matrix multiplication like tf dot matrix and pass the two matrices and then command to. You can transpose the matrix like tf dot transpose. TF dot transpose. So see, this is the matrix multiplication of the two matrices M1 M2, and this is a transpose of the matrix M1. So when you write the code, you will not use these directly, but when you are writing let's say when you are writing neural networks from scratch and not using the Keras API, so then you use these functions unless there is no requirement for these. And the one function that we'll use is the one hot function. What it will do is that it will perform one hot encoding on our labels. So let's say if we have a bunch of classes like class c is equal to tf dot constant. Let's say our data set has these classes 0 comma 1 comma 2, and the let's say 6. No, 6 would be a bigger number, so let's change it to 4. So what we can do is we can write tf dot one hot and pass the list of the labels, and then pass a depth. That would be the actual number of classes that our dataset has. So here our maximum is 4, so we'll pass 5 because it would include 0 also. So see, what it has done is that it has taken the index values, and where, let's say here it has 0 value, so on the 0th index the value is 1. So this is how our model works. The yesterday that I had told you, that on the last layer we have number of perceptrons equal to the number of the classes. So this is what the shape it would require. So I think that's it for today. We'll learn more about keras and TensorFlow in the next session that we'll have on tomorrow. If anyone has any doubts or any query, they can just write in the chat box, or they can just speak up.